For the first question, we have to simplify 27 raised to the power of 5 divided by 3. So we have 27 raised to the power of 5 over 3. First thing is just to apply the law of indices that allows you to deal with the numerator and denominator of the power separately. So I can have this. Remember, the denominator becomes the root, and then the numerator becomes the power. So you have cube roots, because the denominator is 3, of 27, all raised to the power of 5, right? So cube root of 27 will give you 3 raised to the power of 5, right? And this would give you the result 243, right? So all the very first thing to do is 27 raised to the power of 5 over 3, express the powers as splits, right? Remember, this 5 divided by 3 is the same thing as 5 times 1 over 3. 1 over 3 just means the cube root of whatever is inside, then raised to the power of 5. Cube root of 27 gives you 3, then raised to the power of 5, which gives you 243 as your final result. This solves the first mini drill question. Let's move to the next mini drill question. Now we have the next question, which is 3 raised to the power x equal 1 divided by 81. So the very first thing is try as much as possible to simplify the big numbers into smaller indices. So now we have this 3 raised to the power x on the left hand side. This is simplified enough for us. Now we have the right hand side, which is 1 divided by 81, right? Let's look at 81 in itself. We can split this in terms of indices as a multiple of 3. I can write 81 as 1 divided by 3 raised to the power 4. So I can write 81 as 3 raised to the power 4, right? Which is 3 times 3 times 3 times 3, which is 81. So writing 81 as this, the next thing I have to do is I can find a reciprocal on this right hand side. I have a law of indices that deals with reciprocals for me. If I have a reciprocal, that simply means that I can translate it as a negative power. So the reciprocal simply becomes the negative part of whatever power I have at the denominator. So I have 3 raised to the power x equals 3 raised to the power minus 4. Now, the base on the left hand side is the same thing as the base on the right hand side. So I can equate the power. So if I equate the power, I will simply have that x is equal to minus 4 as my result. This solves the question. So I have 3 raised to the power x equal 1 divided by 81. First thing I have to do is take 81 and simplify it. I simplify it as 3 raised to the power 4. Next thing is I apply the reciprocal law, or the negative power law. That is why if I have a reciprocal, I can convert this as a negative power. So this gives me 3 raised to the power minus 4. Now, if I have this, since the base on the left hand side is also equal to the base on the right hand side, I can equate the power. This simply gives me x equals minus 4 as my result. This solves the second mini drill question. For our third question, we have to solve 3 raised to the power y equals 243. Now for this case, we just have to find the value of y. That's all we need. Now to do this, the very first thing we have to do is express the right hand side as a simple indices. We already have a simple indices for the left hand side, so it means we have to just rewrite the right hand side as a term expressed with the base of 3. Now to do this, we have 3 raised to the power y equals 243. Now you can express 243 as 3 raised to the power of 5, right? If this is true, then since the base of the left hand side is equal to the base of the right hand side, we can go ahead and just equate the power. So equating the power, we have that y is equal to 5. This answers our question simply. So we have solved 3 raised to the power y equals 243. The very first thing to do is take the right hand side and simplify it as a multiple of 3. We have that as 3 raised to the power 5. Since the value, the left hand side as the base is the same thing as the value of the right hand side as the base, we can go ahead to equate the power. So we have this as y equal to 5. This solves our third drill question. So now for our fourth drill, we have to simplify 0.0001 all raised to the power of 2. So we have to simplify this. So the very first thing we can do is convert this first and foremost to standard form, then expand it. So we have 0.0001 all raised to the power of 2. We can convert this to standard form. This is the position of the decimal point. So we have 1, 2, 3, 4 movements towards the right, so it becomes a negative power. So we have this as 1 times 10 raised to the power minus 4 raised to the power of 2 outside. Don't forget, 1 times 10 raised to the power minus 4, in fact, 1 times any other number gives you that number back. So 1 times 10 raised to the power minus 4 is the same thing as saying 10 raised to the power minus 4 all raised to the power of 2. Now, at this point, we have two powers, so we can just multiply these powers. So you have your answer as minus 4 times 2, which gives you minus 8. So your final result will be 10 raised to the power minus 8. So to do this question, we have just simply, first and foremost, converted to standard form. We got 1 times 10 raised to the power minus 4, which is 10 raised to the power minus 4, and then expanded, which in due case is just to multiply the powers. So minus 4 times 2 gives you minus 8. So your final result is just 10 raised to the power minus 8. This answers our fourth drill question. So now for our fifth drill question, we have to simplify 2r raised to the power 5 times 9r raised to the power 3. Right? So all we just have to do is expand this and multiply this by our laws of multiplication. Right? So for 2r raised to the power 5 times 9r raised to the power 3, we can group this and multiply the numbers and then multiply the variables. Right? So for the numbers, we have 2 times 9, and then times we have r raised to the power 5 times r raised to the power 3. Of course, 2 times 9 will give us 18. Then times r raised to the power 5 times r raised to the power 3. This is multiplication, so it just means we are just going to add the power. So you have r raised to the power 5 plus 3, right? 5 plus 3 will give us 8. So we have r raised to the power 8 on the variable side and then 18 on the number side. So 18 times r raised to the power 8 will just give you 18 r raised to the power 8 as the final result. Right? So for this question, it's pretty straightforward. All you just have to do is just apply your multiplication operation on those values. For the number side, multiply them, you get 18. For the variable side, multiply them, r raised to the power 5 times r raised to the power 3, you get r raised to the power 8. Multiply them together, and then your result will just be 18 r raised to the power 8 in simple terms. This completes all our drill questions and also wraps up our journey on indices. Of course, indices is just a concept meant to simplify big digits, big numbers, or big values with the aid of our laws that we can use to operate on them. So we have looked at those concept of indices, we have also looked at the laws of indices, and we have also applied them. All that is left for you to do now is to take these examples, take these drills, and solve and